Welcome to the Molecular Moments Podcast.
In today's episode, we sit down with our guest, Dr. Neil Spooner, director and founder of Spooner Bioanalytical Solutions and senior editor of the journal Bioanalysis. Neil is a veteran of the bioanalytical industry who turned his pioneer work in the bioanalytical field into a highly successful and one-of-a-kind consulting firm. Neil is a guy who chases his passions. He brings unique insight, experience, and excellence to everything he does. I hope you'll enjoy our conversation. We're talking science, as scientists do. So without further ado, here's another can't-miss episode of Molecular Moments. Welcome to the podcast, Neil. I'm delighted to have you join me today.
Hey, Chad. I'm honored to be here. I'm excited to spend the next 45 minutes to an hour with you.
Fantastic. Can we start with you giving us a few highlights of your career in the bioanalytical field?
Yeah, absolutely. I guess from when you were talking about bioanalysis these days, a few years ago, bioanalysis used to be defined as being from an LCMS background or a non-LCMS background. I guess those boundaries are blurring now, which is a fantastic thing. I'm from the LCMS background, and I first got into mass spectrometry towards the end of my degree, working on a VG double sector instrument, if anyone knows what those things are. And after I'd done my PhD at the University of Liverpool, I'd heard about this newfangled thing called LCMS, and people were saying this is something you need to get into. But there weren't very many around, so I did a postdoc at the University of Bristol using an early Finnegan TSQ70 with thermospray on it, which is, if anyone's ever tried to do thermospray, it's not an easy thing to do to get consistent ions. But from there, I was felt a little bit more confident in LCMS, and I got my first job in industry at Huntingdon Life Sciences in, I guess that was 1994. So a contract research organization that's now part of the LabCorp empire. Stayed there for a couple of years and learned how to use SciEx API 3, as well as some other Finnegan sector instruments for doing metabolite ID. But that's where I first got my proper taste of quantitative bioanalysis, doing extracts and things, and met a bunch of lifelong friends in the bioanalytical field there, and doing everything from veterinary products, doing liquid extractions in the dark, because we had a photosensitive veterinary product. Having to do this liquid extraction of tissues in the dark was always pretty challenging. And that's where I first met Labrus Grant as well, of LabCorp. Mm-hmm. Got him involved in helping to carve up these pieces of meat and kidney and liver and things that we had to extract.
So you had Russ Grant doing the work for you. Is that what you're...
we worked together. I think he came in telling me something like his brother-in-law or something was a butcher. So I said, I've got just the job for you. I've got some kidneys, liver, meat and fat that needs cutting up. And it was pretty ugly. There was a lot of blood. It wasn't very pretty, but I think that was kind of his first week at Huntingdon Life Sciences. He tells that story as well, so it's no secret there.
Yeah, well, and now Russ lives near me here in North Carolina, so I might use that as an excuse to get together and ask him some stories from the old days.
Yeah, he's got a lot of stories. Yeah. So a couple of years at HLS, interesting place to work, learned a lot there, doing bench science there, meeting a lot of good people, and finding out that type of contract research organization, as HLS was at the time, wasn't the place where I wanted to be. So I was busy just writing a lot of letters. And eventually, Susan Fowles at SmithKline Beecham took pity on me, brought me in for interview and gave me a job at SmithKline Beecham in the UK at the time. She actually, when I moved to the States, gave me one of my letters that she'd kept and framed and gave it back to me. So she was the one that I guess gave me my first break. And I worked at SmithKline Beecham, GlaxoSmithKline for 20 years. Spent 3 years in the US from 98 to 2001 at the Upper Merion facility. And it was while we were in the US that our first daughter was born. So she's a dual national. But the merger brought myself and my wife back to the UK. And our second daughter was born a couple of months after we returned to the UK. So she's not a dual national and still holds that against us to this day. But worked at GSK for 20 years in various positions, mostly quantitative bioanalysis, also headed up a metabolite ID group, got involved in some projects, got involved in leading the implementation of new technologies. How can we do bioanalysis different rather than just doing it the same way? And that's where we got interested in microsampling and dried blood spots, basically coming from a need to do pediatric studies and how do we deal with really small samples from really small people. And we saw some work published by Kevin Bateman at Merck that he'd done with Discovery and some other work, obviously, elsewhere, and just got interested in dried blood spots. And from then, all the microsampling technologies and started to bring that forwards. But after 20 years at GSK, they had a change of direction. They no longer really needed the kind of role I was doing. And I got the opportunity to take redundancy and decided to set up on my own. So that was 6 years ago, set up my own consultancy. Didn't really want to do what a lot of other consultants do in terms of overseeing outsourcing work from small to mid-sized pharma. I thought, I can do that. I know how to do that. I'd been involved in outsourcing work with preclinical and clinical work, been setting up contracts with CROs. I knew how to do that, and I knew how to oversee regulated bioanalysis. But I thought maybe there's something in this technology piece that I'm really passionate about that I can actually make a living out of. And thankfully, for the last 6 years, I have been able to scrape through a living, helping different kinds of organizations just understanding what patient-centric blood sampling is, what microsampling is, what it isn't, what the technologies are, helping technology companies understand their technologies and helping them move that forwards. And not just working with microsampling, but analysis. How do we analyze these samples that are now in a different format? And how do we deal with the data? And also just looking at other technologies that maybe in the future will challenge how we do analysis. You know, at the moment, the way we do analysis, collect samples, make plasma, freeze sample, ship sample, defrost sample, analyze it, get data, it's unchanged. And I think there's some benefits to maybe shaking up the apple cart a little bit on that one. And I think the technologies are coming through that in the next 10 years, maybe we'll see something a little bit different there and a bit of a change in the way we do bioanalysis that might make it more accessible, might make it cheaper to do, and not rely on the same old workflows. So that's kind of what I do now. That's hopefully a tour de force of where I'm come from and a little bit of where I'm going.
Thinking back, so I want to talk a lot about what you're doing now because it's super interesting with the patient-centric sampling and where that's coming from. But I wanted to step back a little bit and think about those 2000s to 2010, kind of in there with bioanalysis and the regulatory evolution over those years. Because one of the things I've noticed is I think some of the people that are just coming into bioanalysis now that didn't experience some of the challenges of the evolving regulations of that period maybe missed out on some lessons. What would you tell a little bit of a story from your perspective on living through that period, running regulated bioanalysis groups in big pharma in Europe, and some of the lessons you think should be passed on to the people coming into the industry now?
Yeah, I guess it's always a time of changing what we do. You know, it's the way bioanalysis is done now. I think it's less, certainly within pharma, it's less of a defined science now. The bioanalytical groups within pharma are much smaller. They have a lot of challenges. They have some really exciting challenges. You know, the different modalities, modes of delivery, kinds of molecule and the techniques available now are much, much greater than they were when I came through. And I think that's continuing to evolve, as are the regulations that have to surround this, because figuring out how to regulate the validation of some of these new approaches is quite different to validating an LCMS method. So yes, I think it's still changing. But I think the definition of a bioanalyst in pharma is very different to the definition of a bioanalyst in a CRO. I think the bioanalyst in the CRO is much more like what the kind of training I came up through, the bench bioanalyst who is solving problems sometimes, but the main job is to get on through the samples and get the data out there. Whereas I think the bioanalyst in pharma now is, if they're doing an analytical job, they're much more of a problem solver. You know, how do we deal with this tricky technical problem with this weird molecule or this weird mode of delivery, or wanting to measure free versus bound or different parts of a molecule, you know, is a lot more challenging. But I think a lot of bioanalysts, their job scope in pharma has broadened a lot now. They're now expected to do a lot of the activities that in the past a project rep would have had to do. So they're interacting with more people. And I think that's great. You know, they're maybe not learning their trade in as depth as we did, but they're learning a lot more about drug development, and they're finding out a lot more about where their samples come from and where their data goes. And that was always a big bugbear of mine in the traditional bioanalytical lab. In fact, I even had a boss who really didn't care where the samples came from or where the data went. He was just interested in the bit we did, which is so short-sighted in my opinion. You know, you've got to know why these samples have been generated, what the disease is, why you're doing this analysis, and then have an interest in what's happening to the data and what it's being used for, and making a difference to patients' lives, you know, not just making a bottom line for your company. And I think the best pharma engage their CROs in that kind of way as well. And they engage them in that, because there is that big danger that once you outsource a function, and some companies see bioanalysis as a commodity, once you're just putting that out there, there's this risk of just, you pay your money, you get your data. And I think the best pharma company CRO relationships are really that. They're a two-way relationship where they bring the CRO on board. And so I think the relationship is changing. And whilst me from 20 years ago dropping into a modern bioanalytical lab would probably still be able to muddle on through in the bioanalytical lab, I think the surrounding things have changed hugely. And I think that's for the best. I think this broadening of expertise and experience for the bioanalytical science is a good thing. And it's thankfully forever evolving. And so long as we keep on training our next generation bioanalysts in the basics of problem solving with analytical science, as well as understanding drug development and pharmacology, I think they're all important skills. So they have to know a lot more now. I think maybe there is less widespread respect of the in-depth analytical expert now, though. They're going to be harder to come by in the future, because it's harder to get that in-depth training these days. And the tools we all use are going to become more black box-like. And that's probably a good thing, so long as they keep on working, and so long as an analytical challenge doesn't come up that maybe you have to think of a different route.
The best thing for us would be to have LCMSs as turnkey as an automated analyzer in your clinical lab, and we're not there yet, but certainly that makes sense for drug development and moving forward in the industry. So it'll be interesting to see as we continue to move in that direction. But I feel like in the last 10 years, whereas kind of 2000 to 2010 was that slow shift in regulatory changes and things, I feel like since 2010, so much new science and new things have come into it, whether it's unique modalities in the biotech field with different kinds of antibodies and proteins. We're using flow cytometry routinely in bioanalytical labs, and now cell and gene therapy has completely upended everything we ever thought about bioanalytical and what our roles are. But also, as you alluded to, your early work in microsampling, which was the first, I would say it was the first time that I saw some of your talks and came to know who Neil Spooner is. You were at one time kind of the dry blood spot guy making the speaking tour. So define for our audience, what is microsampling? Some folks might not know exactly what that is, and maybe a little bit of a history of the microsampling and how that became what I think it is today of patient-centric sampling, and COVID has driven some of that. So unpack that story for me, if you would.
Absolutely, Chad. So the story at GSK started with the need to just simply collect smaller samples for pediatrics. There was this whole thing from the MA and the FDA giving you 6 months extra on your marketing license to make 6 months more money of exclusivity. And that's worth a lot of money to pharmaceutical companies if they put in their pediatric indication. So suddenly there was a lot of interest, and we're basically brainstorming how to do that. And that's where dry blood spots came up. And then we started thinking more broadly. We started thinking about non-clinical work as well. And why are we doing these rodent studies where we're having to run separate satellite animals, which are between 30 and 50% of the size. The animal numbers are 30 to 50% of the numbers of the main study animals, and they're just there to measure the toxicokinetics. We're not measuring any endpoints, so we're ending up getting this toxicokinetic data in a different bunch of animals to we're getting the actual tox endpoints. And could we join those together by taking smaller samples? Could we use less animals? Could we use techniques that were less harmful to the animals and thereby get cheaper studies, fewer animals, and get better data? So the more we thought about the solutions for non-clinical, there was the pediatric. Then we started thinking, well, maybe these formats of samples enables us to do things that we can't do with standard sampling. If we've got a dry blood spot sample that's pretty stable and can be mailed and we can save money in that mailing, can we move this blood sampling to a different place that's more convenient to the patient? So we really went through that adventure with dry blood spot sampling. But what we found was, with a lot of scientific work, that the quality of data generated by traditional dry blood spot sampling, while good for many applications for making decisions, for the kind of decisions we needed in the pharmaceutical industry, just wasn't good enough with the hematocrit effect. So we started having a lot of conversations outside with different vendors saying, can you get us something that normalizes for this hematocrit effect? Can we collect a fixed volume, or can we normalize in some other way? And it was through those conversations with people like James Rudge at the time at Phenomenex, who then went away and scratched his head and came back to us with prototypes of the meter sampler. And it was at our labs that, we gave him the paper, he was chopping them up, and Phil Deniff was working in the lab with him to show that the data was good enough that he took back to Phenomenex, that led to them forming Neoterix as a separate company, which is obviously now owned by Trajan, and having similar conversations with other companies. And suddenly you got this explosion of new technologies that collected a higher quality sample, and in different means, whether it be a finger prick, whether it be on the upper arm, but in manners that didn't require traditional venous phlebotomy, and sort of opened all our minds to, okay, we can maybe move our blood sampling to a different place. And it doesn't need to be clinic-centric. It can be patient-centric. It can be, what does the patient actually need? That, I think, switched on lights for many in the industry. These technologies kept the benefits of the dry blood spots, but built upon that and made it higher quality, potentially higher quality data than plasma, but no one dare ask that question. And just getting that data in a simpler way for the patient. And, traditionally, everything we've done has been based around the needs of the analytical scientist, the volume of the sample, the format of the sample, the tubes it's in, whether it's plasma or whatever. And suddenly we start thinking, well, what is it that the patient needs? And isn't the patient needs at least as important, if not more important, than the needs of the bioanalytical scientist. And we're starting to see that shift in thinking that if you put the patient at the center, then maybe you can recruit clinical trials more quickly. Maybe you can keep patients on clinical trials for longer. And that's the really expensive bit. It's really difficult to recruit and retain patients onto a clinical trial. And by putting the patient at the center and thinking about that, rather than just pandering to the needs of the bioanalytical scientist, maybe we can run better clinical trials that are quicker and cheaper and give better quality data.
So Neil, you founded, I believe you were the founder of the Patient-Centric Sampling Interest Group, and a wonderful group. I'm honored to be a part of it. You welcome all comers, anyone who's interested to wanting to be actively involved. One of the efforts you had been working towards is a clinical trial to demonstrate some of the benefits to the patient with more patient-centric sampling. Can you talk about that trial and how that process has gone?
Absolutely, Chad. And thank you for mentioning the Patient-Centric Sampling Interest Group, because it is a big passion of mine. It's a group that's free for anyone that's interested in progressing these technologies. It's free for them to join. No one has to pay. It's just reliant on people putting in their time and resources to make things happen. And one of the things we're making happen is running across organizations is a clinical trial. We were hoping to start it about now, but with the latest COVID wave in the US, we're putting that back because it will unduly influence the clinical trial. But the aim of the clinical trial is to understand something that to all of us is common sense, but there's actually no data to prove it. And that is whether home sampling versus in-clinic sampling helps recruitment and retention on a clinical trial. So we've basically been able to design a clinical trial. We're measuring a marker of alcohol consumption, but we're actually not interested in that at all. That's just a way of attracting people in without dosing a drug to anyone and putting ourselves at an insurance risk as an organization that has no money. So they get some data about themselves and monitoring their alcohol consumption over about a month, taking 3 blood samples. But they're randomized without knowing that there's an option to either be sent into a clinic on 3 occasions, about 10 days apart, or getting sent some samplers at home and taking samples at home 10 days apart. And basically, we're going to monitor their behavior. We're going to monitor how many of them see the initial information, how many of them consent, how many of them take the first sample, how many of them take the second sample, how many of them take the third sample, and how interested they are in the data that they get. And that's going to give us some phenomenal data that the industry is really interested to hear, because, as I say, we all think these technologies will help recruitment and retention in clinical trials, but there's no data to actually prove that. So we're very excited to do that, and hopefully we're planning to go back to ethics in March and start the clinical trial in April 2022. And so we should have some preliminary data by the end of the year, and the plan is to publicly share that through publications and presentations. So it's very exciting, and that really has been a community effort. People have built us websites, they've built us databases, they've built us reports that will face into the final report that the patient will get. People have just given their time and their resources for free. It's phenomenal.
It's tremendously exciting, and I love seeing, I don't know if we'd call it a crowdsourcing effort or what we'd call that, but as I said, I'm a member, and you've graciously let me join, but I've been more of a spectator, I would say, in the action, but really excited to see that moving forward. So maybe our discussion today will help drive some more people to join and some contribution. It's interesting to hear that this trial to move patient-centric sampling forward has been delayed by COVID, but I think you might also say that patient-centric sampling and patient centricity of clinical trials has benefited from COVID in some ways out of necessity. Do you think that's true? And can you tell us about what you've seen?
Everywhere that I speak to people, whether it's in pharma, CROs, or indeed the technology vendors, have said it's made a step change. People just simply didn't want to go into clinical study centres because of their fear of catching COVID. And so the industry has had to figure out ways of keeping their clinical trials going for the last 2 years. And while we were all talking about decentralized clinical trials and patient-centric technologies before, it's really come to the fore. And, even outside of pharmaceutical drug development, we've seen this happening. Drive-by testing, home testing. Now in the UK, we're all able to get as many lateral flow tests as you want. People never even heard of what a lateral flow test was until a year ago. And now every British school child tests themselves twice a week in order to go to school. We have piles of these things. Before we meet any friends, we test ourselves. So home testing, from being a foreign entity, has now become commonplace. Okay, that's swabbing your nose and your throat. But a part of that is also, it's now in many countries routine to do an antibody test as well as the antigen test, and that's a blood test. And maybe the microsampling approaches that they're using aren't the most patient-centric, having heard some stories of how it works. But the fact is, people have got used to, because certainly in the UK, every person that tests positive for COVID has their antibody measured through a blood sample. So that's suddenly become tens of thousands, hundreds of thousands, millions of people got used to having blood samples taken in the home, and that's happening around the world. So the barriers have really come down, and all the people that said this can't be done, a high enough quality sample cannot be collected, are now coming back and saying, oh, what was that technology you were talking about 3 years ago? Could you just remind me of that, please? Because I've got this really important clinical trial, or I need to, just in routine healthcare, we need to make measurements that we couldn't before, and people still need blood samples taking. So yes, I think COVID, while a disaster for the world for the last 2 years, has really pushed forward patient-centric sampling technologies. Although for our particular clinical trial, it would just put too much of a bias on the outcome of the study and would be a waste of time if we did it at the moment.
Yeah, for years it felt like microsampling was a bit of the tail wagging the dog. If the bioanalytical scientists were the tail and the dog was the clinical trial planners and designers in pharma, and we were offering up what we thought was a better solution, but it was just too much to move. And now with COVID and the pandemic, as we've seen in other areas as well, I think the patient centricity has benefited. I think the work that we did leading up, we as an industry, that is, leading up to it, certainly benefited society now with COVID to enable some of the testing that you talked about. And clearly, when you talk about your work with PCSIG, the Patient-Centric Sampling Interest Group, you're a senior editor of the Bioanalysis journal, you are all about working together across boundaries to get stuff done. I've had many conversations with you at conferences when we used to do those things, and it's always about how can we advance the science together? How can we join hands and make this happen? So tell me about some of that work you've done. I mean, you talked about PCSIG, you talk about the bioanalysis zone, and just giving back in general. Neil Spooner is a guy who gives back.
Thank you, Chad. I think it's really important to work across these boundaries. What always frustrates me is when analytical scientists just talk to analytical scientists and then are surprised that no one adopts their brilliant ideas. What we learned with patient-centric sampling is you've got to get out there and you've got to talk to all the stakeholders and find out what it is that's bothering them and what it is that they need. And you can't force a new technology on anyone. So you've got to talk together across boundaries. So whether that be, Forum, CPSA, Mike Lee's very good at bringing together people from different backgrounds to just have these kinds of conversations that don't happen elsewhere. And hopefully the patient-centric sampling does that same kind of thing. So yeah, I'm a great believer in when we train our next generation of bioanalytical leaders, a key part of that leadership is breaking down these silos we all seem to like to live in and just walking into someone else's office or picking up the phone and starting a conversation. And before you know it, you find out things are different to what you think they are. And always key to me, and we often still forget this, is asking the opinion of the clinician and the patient. There's been a few studies I've been involved with since I've been a consultant, where I've said to the company I'm partnering with, can we just have a conversation with the clinician who is the representative of the patient? And they've kind of poo-pooed that, but I persuaded them to. And what you then find out by having that conversation with the clinician is often you can do different things to what you thought you could do. And certainly I've been involved in a couple of studies with neonates, and thinking that we could only do one thing, and you talk to the clinicians and you find out, actually, no, there's another route. And actually that route was simpler than what we'd all second guessed, what would be said. And we got a better solution with a better quality sample, which probably led to better quality data than we would have had without having that conversation. And so just have those conversations. And so as we all move forward in our careers and work with junior scientists, just helping them to open doors to other parts of the organizations we work with, because that's, at those interfaces, that's where the magic happens. That's where the new ideas happen. And that's where we simplify things. Because I think things could be a lot simpler than they are. We get stuck in this dogma of we've got to do it this way. And when you actually examine that dogma, often we blame regulators, but actually you look at the regulations and you talk to the regulators and they say, it's not us. We're not telling you to do it that way. You've made this up for yourselves. You've made a bunch of rules that you didn't need, right. And you've made it hard for yourselves. And I think we're really good at doing that. So I try and challenge that in a gentle way where I can.
Tell me a little bit about your role in the journal Bioanalysis and how that's evolved. For me personally, I feel like bioanalysis has really filled a niche in the last 12, 13 years, that it's become a very integral part of everything we do in bioanalysis with the zone and the journal, and it's really given us a home. And I'm not paid to advertise for those guys, but I just think that it's a business, but they've also done us a great service, I think, in the same space, and you're heavily involved there. I'd like to hear about that.
Yeah, absolutely. So I've been senior editor at Bioanalysis since 2014, so quite a while, filling on from Howard Hill and Brian Booth, who got that going in such a fantastic way and set that direction. And, hopefully I just helped keep them going with how they think about editorial direction, how they understand where bioanalytical science is going, and helping to integrate them into the community and not just be a publisher that is separate, that just takes papers and publishes them, but actually goes out there and asks questions and solicits content and solicits special issues to just focus on things. So we got the journal, which is a little bit more of a formal academic type thing, but then you get the zone, which does this kind of thing. It talks to people, it breaks down those barriers, it brings in other opinions and interacts with the world in a different way to dry black and white newsprint. And, increasingly, as we're all getting more used to listening to podcasts or watching interviews or watching people chatting, I think that really helps. It personalizes it. It gives people chance to explain concepts in more human language. People actually having conversations and talking about the real life of a bioanalyst rather than the academic black and whiteness. We still need that whole black and white journal thing. But the broader conversation, like we're having here today, is just as, if not more important in actually moving our science forwards and doing things differently and breaking down boundaries where they need to be broken down and doing things to bring good medicines for the benefit of humankind.
Neil, earlier you talked about leadership and that next generation of leaders and how it's going to be different, that next generation of bioanalytical scientists, really. And I'd like to hear about some of the people that were mentors to you and how you are carrying that through to be a leader and generate the next generation of bioanalytical leaders. What advice can you give from your experience?
Yeah, I guess mentors, one of the strongest ones, I guess, was Susie Fowles, who was the one that recruited me to SmithKline Beecham, who sadly is no longer with us. She died a few years ago in a car accident that happened in Greece. But she gave me that first break and then, trusted in me to take on increasingly senior roles and encourage me in that. And really helped with the microsampling and the dry blood spot implementation at GlaxoSmithKline. She was able to break down barriers that I didn't even know were there because she was more experienced and she was just helping behind the scenes as well as coaching. There was some tough love there at times. We've all got stories to tell about it, but I learned a lot from her and she certainly helped move my career forwards. I hope I can do similar. I have a visiting position at the University of Hertfordshire where I get involved. I do a little bit of teaching with undergraduate students, not very much. I'm involved with a few PhD students and postdoc students. And hopefully through working with them, I'm able to not just help work them through analytical problems and scientific problems, but, think through their career paths. We've all had complicated career paths. And University of Hertfordshire has a background of a lot of the students there. They're first in family to university, and PhD students from a variety of backgrounds that aren't privileged. And for them, working through how to get into the world of science is just as important as getting their degree or getting their PhD, and able to have some great conversations there. And it is something that with the role I have now, it is something I'm planning to do more of as I get older and grumpier. Hopefully I can work with some more early stage scientists, whether they're still at pre-university, even at school. I've been talking to some friends about maybe what we can do in schools a little bit better, as well as at university, and people who are early on in their careers at pharmaceutical companies or CROs or technology companies, and just, again, helping them to see a bigger picture of where they might fit and where their careers might go. Because I think careers are very different now as well. People move companies more quickly. Companies don't try to hang on to people as much as they used to. And it goes both ways with this current generation. So all of us figuring out how to live in this new world, and this new world where work isn't necessarily the workplace, as we've learned with COVID. There's challenges. What do we do with early career scientists who maybe aren't coming into the lab as often as they used to? That's an interesting one as well.
Yeah, and that is interesting because in the case of CROs, it's been challenging. I think the people who work in the lab and have their hands on have to be in there in the lab, but I think they found that in many cases their managers haven't been there as much.
Absolutely.
And that's quite often out of necessity. If you don't need to be there, you aren't there. And I worry across the industry, not just within my company, but I worry across the industry that if people aren't missing that sitting down in a meeting face-to-face with data printed out and taking a look at it, or maybe even if it's on a laptop or up on a screen, it's a different interaction than what you normally see. And the other thing I guess I would like to share with you, Neil, is I think you're also underestimating some of your personal impact on the industry and through the many talks that you've done on dried blood spots and patient-centric sampling, and your presence and the work that you did with GSK, just I'll say in general, bioanalytical, moving the industry forward. There are a lot of people who looked at you and looked at what you were doing in the people you developed. I've seen it, and so you've touched the industry in a lot of ways. So it's exciting to hear you reach out also through academic opportunities and other ways also. I wanted to talk to you about some of your other passions, because I think it's always interesting to hear how we scientists spend our time with other areas and different places they get into. I understand that, I don't know if it's similar to, Prince Charles or in his passions with produce. I wanted to throw that at you, but I understand you make a lot of your own produce, cheeses, wines, flavored gin jam, which I'd like a bottle of next time I'm in the UK.
Yeah, I like.
Tell me some about this. Tell me about these passions.
I guess it's the frustrated bench scientist in me that hasn't been a bench scientist for a very long time, but using those same skills to make food. I guess making cheese is fun. Watching this liquid turn into a solid and then something that's tasty to eat and tastes better than anything you can buy from the shops. Same with just growing your own produce and then finding ways to either turn it into alcohol, turn it into pickles or jams or whatever. It's kind of fun. And, my poor family all get a basket full of presents every Christmas. And they seem to keep on coming back for more. So it must be okay. But yeah, it's just a lot of fun. And it's just part of doing something a little bit different from just doing science all the time. And it's a way of relaxing. I find it's important to just find space and time, whether it's walking the dog, gardening, or making things. It kind of just frees up the mind a bit. It relaxes you. And that's certainly where my best ideas for doing something new or doing something different or starting a new collaboration or things like that. That's the moments they happen. It's not answering my daily emails that these things happen. It's when I'm walking the dog and when I'm making wine that this stuff happens. And I think we all need to find time to free that up. And it's what also used to happen when we were face-to-face at conferences. The best conversations were always the ones in the corridors and in the bars. And that's where the creativity came, and that's where the new connections came, and that's where we broke down those barriers and had those new ideas that hopefully were carried on beyond the conference. So yeah, I like making stuff. It frees up. It's relaxing. It takes the stress away a little bit, and you got something to show for it. Whereas end of the day with 5 hours of teleconferences and 4 hours of emails, you've often not got a lot physically to show for what happened today. I talk to my daughters in the evening and my wife, what did you do today? I did a bunch of teleconferences and emails, pretty much like yesterday.
Same story for me, Neil. Same story for me. Well, today we can say that we produced a podcast, and that's exciting. I've really enjoyed. I've learned a lot from you today, even as a guy that I've known for probably 15 or so years. A lot of insights. I can't wait till we can get together again. I can't wait to try some of your gin jam, even though I have to admit I don't have a clue what that is.
No, gin and jam are separate things, Chad.
It's gin and jam. Oh, yeah. Gin and jam. We missed a comma. Okay. Well, that's okay. Gin and jam.
We just created a new thing. Let's make gin jam. I like the sound of that.
I'm in. So Neil, I want to thank you for being on. I really appreciate it. Are there any last thoughts or comments that you have for us as we wrap up another episode of Molecular Moments?
No, other than to say thank you for this, Chad. This has been fantastic. 45 minutes or however long it is we've been chatting together. Mm-hmm. It's flown by, and I think this kind of communication is just fabulous. It's thank you to you and your company for providing this as a resource for all of us, because it's we get to see each other as human beings and other sides of each other compared to stale emails and publications. So yeah, thank you so much, and thank you for inviting me. It's been fun.
Thanks, Neil, and I agree. It's been a wonderful opportunity that my company has given me as well to have conversations with great people like you. So that's all for this episode of Molecular Moments. If you enjoyed today's episode, be sure to subscribe on Apple Podcasts, Spotify, or your favorite podcast app so you never miss a conversation. If you'd like to hang out with us, BioAgilytix, outside of the podcast, We have many webinars and other presentations available for your enjoyment and education. Visit bioagilytix.com to see what's coming up and how you can stay in touch.
Thanks for listening to the Molecular Moments Podcast.